AZMerit review number 1. 1 through 4 you are asked to review, and very few of these problems is a calculator going to be useful. There are a few problems where it is useful. So again, as I work through number 1 is like number 2, number 3 is like number 4. So for you, maybe it's helpful for you to watch me do number 1, and then you go ahead and do number 2 while I'm doing it, especially if you can do it a little faster. Okay, so what do we do here? Asked to simplify. First, I'm going to examine the exponents inside. 7, 5, 2, and there's not an exponent here. There's actually a 1. Then for myself, I like to first distribute. So when you distribute, you multiply. So I distribute the exponent to every exponent inside. That gives you x to the 21, y to the 15, all over x to the 6th, y to the 3rd. How did I get that? 3 times 7, 5 times 3, 3 times 2, 3 times 1. Now I'm going to look at their like terms. When you're dividing and you have the same base, you subtract exponents. And there's a few different methods to getting the correct answer. The one I prefer is look where the larger exponent is. For the x's, it's on top. Take 6 away from 21 to get 15. Larger exponent was on top. Larger exponent's on top. Take 3 away from 15 to get 12. Larger exponent is on top. Problem done. A calculator was never useful there, so I'm not going to circle it with a highlighter. Number 2 is exactly the same concept. Feel free to work on it on your own while I do it quietly. So first I looked, and I could see that there was a 1 on the 2 and a hidden 1 on the 3. Now when I distribute, 2 times 1, 2 times 3, 2 times 1, and 2 times 4. 2 squared and 3 squared don't reduce. When I look at the like terms, again we have the same base and we're dividing, so I'm going to subtract. This time the larger exponent's on the bottom. So take 6 away from 8, you get 2. The larger exponent is on the bottom. Your answer remains on the bottom. Can you raise your hands 1 to 5? How well do you understand? Okay, this is a little more tricky, and yes, we can use the calculator if it helps you here with fractions. So there's really like 4 things here. There's a 4, an m, a 27, and an m. Now outside of this parenthesis is a 1. When you distribute a 1, it does nothing. It doesn't change anything. So I have 4 and m to the 5/3. But here, when I distribute, I get 27 to the 1/3. And m, 4 times 1 is 4, 1 times 3 is 3, to the 4/3. So to simplify this, some people can do this in their heads. And by the way, to do this in your head, you go, what times itself? 3 times gives you 27. 3 to the 1st is 3. But if you're in a test and you're a little stressed, how can you do that again? You're going to go 27 raised to the 1/3 power. We get an answer of 3. So this gives you an answer of 3 without having to think. Now I'm going to combine like terms. 4 times 3 is 12. I've taken care of these portions. Now I'm going to combine these two portions. Same base and multiplying, I'm going to add the exponents. So I want to add 5/3 and 4/3, and most people are going to be able to do that in their head and combine because you already have a common denominator. But again, maybe you're stressed out, you're taking a test, grab the calculator. 5/3 plus 4/3. Is that correct what it was? Yeah. Okay. Hit math fraction, enter answer, and the answer is 3. So this final answer is 12m to the 3rd. Done. I'm going to take a highlighter and I'm going to circle number 3 because I could use a calculator to make it a little bit easier. While I go over number 4, you're welcome to do it on your own or to follow at the same pace that I'm going through it. 5 m to the 1/2. Distribute 81 to the 1/4. M to the 5 times 1 is 5. 1 times 4 is 4. Again, if you know this answer is 3, great. If you have not memorized that or understand, you can grab a calculator, go 81 raised to the 1/4 power. You'll get an answer of 3. So this is 3. Okay, combining like terms. 5 times 3 is 15. And now I have m. Again, when you have the same base and you are multiplying, you're going to add exponents. 1/2 plus 5/4. Grab the calculator to make it a little bit quicker if you want to. 1/2 plus 5/4. Math fraction, enter, enter, bless you, is 7/4. Final answer is 15m to the 7/4. Again, a calculator could make this easier, especially with fractions or rational exponents. And we're done with the first section. Okay, so previously when we went over the unit about radicals, we learned how to do them both algebraically and using a calculator. And as I told you earlier, on the AZMerit test, you're not required to show any work. There's going to be very few multiple choice, but you're not required to show work. So here's how I'm going to do this problem. I'm going to treat this like y sub 1, and I'm going to treat this like y sub 2. And wherever these two lines cross, I know I'll have my answer. So I'm always going to start off by doing second plus 7, 1, 2. Go y equals, the first part is going to be x subtract 5. Your second part is going to be the square root of x plus 25. Okay, I'm going to graph it. So as a reminder, I've taken and I've shifted this linear line down 5, and I've taken the square root and shifted it to the left 25. So I can see they're almost meeting. Does everybody see this? We're almost at that point. So I need to just go to the right a little bit further. So I'm going to hit this right now. I'm going to hit Windows, and I want to go to the right. So go to the X's, and I'm just going to go over to 20. Just to give myself enough room, hopefully, to see where they intersect. Okay, I want to know what this answer is. So second, trace, intersect. First curve, second curve, and over the top. Now, a lot of students on your previous test would write down an answer of 11, 6. 11 and then 6. That's wrong. Look at this problem. What variable are you trying to solve for?
X.
What is the only x answer here?
11.
Problem done. 1 to 5, how well do you understand that? 1 to 5. Okay. So I'm going to go through and do number 6. I'd like you to do it at the same time. Please do not start at number 7. I'm going to talk about how there's some confusion with 7 and 8 and 9 a little bit later, okay? So do number 6 at your own pace while I do it at my pace. I always start with second plus 7, 1, 2 to reset it. Did you guys get an answer of 3?
Yeah.
And I'm sorry for asking, is there anybody sitting somewhere where they cannot see? Jesus, do you need to move forward? Yeah. Okay, perfect, Jesus. Can you see him back, Deandra? Deandra, would you mind switching with Jesus? Does anybody else need to sit towards the front so you can see? Thank you, Deandra. Thank you, Jesus. Okay, well, here's why I want you to be careful with this problem. Okay, so it doesn't look too hard. We're going to split this up. This is my first, this is my second. Here's why I want you to be confused. Just watch this, okay? Don't plug anything in. When I go like this and I plug this in, what am I going to raise this to? What exponent do I raise it to?
1/3.
So here's why I don't want you to do it like this. Watch this. When I do it like this and then I go plus 8, does everybody see that? Here's what I'm concerned about. I'm concerned that this calculator is going to read it like this. It's going to read it like this. X raised to the 1/3 plus 8. And it's going to think that that 8 belongs to this exponent. Does it belong to the exponent? So when I plug it in, whatever number is here, I'm just going to put it in front so there's no confusion. So it's going to look like this. It's the exact same problem. I just put the 8 in front so I don't have any mistakes. So I'm going to do it like this. You can do it with me at the same time. 8 plus x raised to the 1/3 power. Y sub 2 is the constant of 2. So I'm going to have a cube root function, which I'm looking at right there, and then I'm going to have a linear function. Okay, so if you remember cube roots, and we enter the end behavior, as you go to the right, it continues to go upward if there's no reflection. As it goes to the left, it continues to go down. Do you guys see how it's going down? Eventually, it's going to hit this line. Now, how far do I have to go out until it hits it? I don't know. Well, let's check. Let's go to Windows. I want to go to the left, so I want to go to the x's. I'm going to just go with the negative 100 right now and see if that's far enough. So really, we're playing with the windows right now until I can see it. See how it's getting closer? Here's my question. Do you agree that I don't really care about this space here or this space here? So when I go back, not only am I going to keep moving it to the left, I'm going to take away some of the space above and below. So I'm going to try negative 200 this time. But, you know, I don't need all this space. I'm going to do negative 5 and positive 5, just so it kind of condenses it a little bit. Here's the cube root. Let's see if we're going to see where they cross. Okay, so they're really close right now. Do you see that? I'm at negative 200. I need to go just a little bit further. I'm going to do negative 225. Okay. This is where it appears to me they cross, right? So let's check. So I'm going to do second, trace, intersect. It's already in one curve. I press enter. It jumps to the second curve. I press enter. I'm going to go over the top of where I believe they intersect. And as long as it's within this window, I should get an answer. Here's my answer. Now, do I put down an answer of 2 or negative 216? I want to hear you talking with your partner when you do number 8. My concern is will you plug it in correctly? So I'm going to give you 2 minutes, and then I'll start doing it quietly on my own. Okay, start talking to your partner about number 8. Begin.
So we start with 2, right? Or no?
So previously, when I worked with a different class, we graphed this and they said, okay, well, this is a cube root function, and I can tell this is a cube root that's been stretched. But where's this other function, this horizontal line? Remember that our window only is going up to a y maximum of 10, and this is already at 17. So I'm going to change my y maximum to 20. Now I can see this is my first y sub 1, it's my cube root function, and this is y sub 2. This is my horizontal, or my second function. I want to know where do they cross. As a reminder, unless there's been a reflection with cube root functions and behavior, as you go to the right, it continues to go up. As you go to the left, it continues to go up. So I know eventually they're going to cross. I have a long ways here to go. So I'm going to start by going out to the right, and I'm going to try 100 first. Okay, 100 is getting closer, but it's not quite there. I'm going to try 150. So I can see they cross right here. So second, trace, intersect, first curve, second curve, and over the top. Okay, your x value is x equals 125. Hands raised if you'd like me to go over this problem with you really quick. Hands up. Anybody have no problem? 1, 2, anybody? Okay, we're moving on. When you plug in number 9, what should you do to make sure we don't have any mistakes? Put in 1 in front. So I only want you to do 9 and 10, and then we're going to talk about how 11 and 12 are a little bit different. With your partner, please do 9 and 10. After each problem, look up to see if you have the same answer that I do. Ready? Begin. Remember, when your y sub 2 is 28, that means you're going to have a horizontal line that's way up at y equals 28. So adjust your window so that you can see that. Second trace intersect, first curve, second curve, and guess. And we're looking only at the x value that we're trying to solve for. So x equals 8. Moving on to number 10. First, remember to clear your calculator. Okay, so remember, we are going to take this and have a horizontal asymptote at y equals 50. So I'm going to go to the windows and already change the y to go above that 50 so I can see both functions. This is different looking, so I'm going to extend this out in both ways. I'm going to try this one. Negative, I don't know, I'll try negative 100 and positive 100 just to see. So to me it looks like there we could have two answers, one at the left here and one also at the right. Remember that when the number in the bottom is an odd, you can have both an even inside and an when the number in the bottom, the nth root in the bottom is odd, you can have both a positive and negative. So that's what this is accounting for. So I'm going to go a little further in both directions. Let's say 150 in both directions. Okay, there we go. So I'm having both these. Let's find those answers. Second trace, intersect. So first curve, second curve, and go to the top. So one answer is 128. Now let's check the second. Bless you. And negative 122 because of the shift. Okay guys, for this last one, how many of you were able to extend out the window to see both of these? Hands up. Now let's actually plug these back in just to make sure this works. So press clear please. If you take 128 and subtract 3, what do you end up with? 128 subtract 3 is? Okay, put 125 in parentheses. Raise it to the 2/3 power, please, in parentheses. Press enter, and take it times the constant of 2 out front. Do you end up with an answer of 50? Okay, that means that this works. Now let's try negative 122. So in parentheses, negative 122 subtract 3. we're going to, oh, I got to keep it in parentheses. So negative 125 raised to the, keep it in parentheses, raised to the 2/3 power. Take it times 2 and you get 50 again. Okay, they both work. All right, now we're going to go over why is 11 and 12 different. Now, yes, please make sure you're listening. You could continue to do the same method with 11 and 12, but there's something easier as a reminder. When you have one item, see how this is in parentheses, so it's like one item? When you have one item on the left and one item on the right, and they have the exact same exponents, you get to cross out the exponents and write down exactly what you see. And the time it would take you to plug this into the calculator, you can actually solve this simple 8th or 9th grade math problem in the same amount of time. Subtract x from both sides. Add 4. If you leave it as a fraction, it would be 13 over 2. Maybe this happens to be a multiple choice problem on the AZMerit, and it says a decimal. 13 divided by 2 is also equivalent to what decimal? 6.5. Either one is fine with me, but again, check your sources. Okay, now how can we make number 12 look like number 11? Talk to your partner. How can we make number 12 look like number 11? Can't take off the 1/3 yet. You gotta take this thing and move it to the opposite side. You can only have one item on the left and one item on the right. See how this is currently negative? So to get rid of it, you're going to add it. Now I have the exact same concept. And yes, you could plug it into the graphing calculator, but I think it may be just as fast to do it algebraically. Please solve. Go ahead. Okay, what do you get for an answer? I think I got x equals negative 1/2 when I reduce it. Did anybody else get negative 4 over 2? Okay. Let's look at number 13. By the way, each one of these we could use a calculator on to make it easier. I'm going to leave these two blank, number 11 and number 12, but if you chose to use a calculator, you could get the same answer. Number 13. Okay, so this 2/3 has to be distributed to 3 things. And as a little reminder, what number here is hiding out front? So when I rewrite this, is really like x to the 1/2, right? So before I do anything, just because I don't want anybody to be confused, this is really what I have right now, right? Okay, here we go. I'm going to apply to each one of these. So this becomes negative 125 to the 2/3 power. And there's a couple different ways you could do this. X to the, okay, now when you distribute, you're going to multiply. 4 times 2 is 8, 1 times 3 is 3, so 8/3. 1 times 2 is 2, 2 times 3 is 6. Don't worry about reducing right now, we'll let our calculator do all this later. Many of you can do this in your head. We've already learned how to do this. So what number times itself 3 times gives you a negative 125, and then square that number. But if not, let's grab a calculator. Maybe you're stressed, it's at the test, you just need a little extra help. You're going to plug in that first term, negative 125, make sure it's in parentheses, raised to the 2/3 power. You end up with 25, okay? So that's this part, 25. Now when you have the exact same base and you're multiplying, you add the exponent. So grab the calculator again. We're going to go 8/3 plus 2 divided by 6. It will reduce it for us. Hit math, fraction, enter, enter. Math, fraction, enter, enter. And we end up with an exponent of 3. Here is your final answer. With your partner, I'd like you to see you do number 14. I will start it in 30 seconds. Begin. Again, if it helps you here, you can plug this into the calculator as 16 raised to the 3 halves, so 64. If you want to refresh your mind, this means what times itself 2 times gives you 16, that's 4. 4 to the 3rd power is 64. When you have the same base multiplying, you're going to add the exponents. 15 divided by 2 plus 3 divided by 4. How many of you were able to get the same answer that I did for 14 hands of pi? Does anybody have any questions about that? Now, I used a calculator to get the fraction quicker, so I'm going to circle this because I used the calculator and made it a little bit quicker. I'd like you to do the following. Please listen up. Listen closely. Please listen. Look up here. I consider this all of page 1. There's a front and back. I want you to find page 2. I want you to go to the back of page 2 and find the problem number 19. Number 19. Clear your calculators. 19 says a college with a graduating class of 5,000 students in a year in 2010 predicts that its graduating class will grow at 6% per year. This is the frequency. This is how often it's occurring. This is your growth rate. This is your initial value. Look to the left of Mr. Cortez right now. See those boxes? Remember how it was final, initial, rate, frequency? Remember those? Okay. We're going to do this one together. We're going to use the variables they ask us to use, which is y for your total number of students and x for the number of years. All right? So with that, we know it's growing. So it's going to be greater than 100. In fact, it's going to be 106%. You're going an additional 6% per year. How do I write 106% as a decimal? So y equals your initial value times 1.06. How often does this occur? Every year. And we want to know after how many years after 2010. How many students will be graduating in 2016? So a big mistake is a lot of students would want to plug in 2016 here. The key is it says T represents the years after 2010. So how many years is this after 2010? Grab a calculator, type in 1.06, raise to the 6th power. Get an answer and take it times 5,000. I came up with an approximation of 7,092. We used a calculator. I'm going to circle it. Please make sure your partner is getting that same answer. Would anybody like me to show you how to do it on the calculator? Anybody? Okay, let's look at number 20. Now 20 is tricky. So 20 is you got to work hard just to come up with the equation, and then we're going to go backwards. So 20 is tricky. Don't try to work hard this time. Okay, it says that we start with how many bacteria cells? So that's cool. They already tell us this is 4,000. That initial value is 4,000. It says after 3 hours, there's this many left over. So this is your final amount. Oh, 18,000, my fault. 18,000. There's this many left over after 3 hours, but it doesn't tell us the rate. We need to find out what the rate is to come up with the equation. So if I'm going to solve for r, we're first going to get rid of 4,000. Please take 18,000 divided by 4,000 on your calculator. Do you have 4.5? 4.5 equals r to the third. How do you eliminate that third power so r is by itself? How do you get rid of this? Raise it to the 1/3 power. Do that on your calculator right now. Please take, and do not round anything right now. Take 4.5 raised to the 1/3 power. So I'm going to write down an approximation here of 1.65. This is my general equation. Using this general equation, please answer question B. So it tells you that we want to know what is the total bacteria that we can expect after 10 hours. So I'm going to take 1.65 and raise it to the 10th power. Then take that times the initial value of 4,000. And I'm going to get a fairly large number here. So there is approximately 598,273 cells. Please check with your partner to make sure they're able to do the same thing on the calculator. When you're done, you're going to take notes. You are writing this down as soon as you get done in this little spot. When you take out a mortgage, you take out a loan for a house or a car. In most situations, now there are some situations you can buy a car with a different interest rate, but in most situations, if you take out a loan for a $20,000 car, are you only paying back $20,000 to people that provide you the money? You pay back a lot more, right? Because of the interest. So this is going to help us figure out how much we have total based on the interest, the amount of time that we leave it in, and how often it is compounded. So we're going to go through this slow, doing number 21 together. Please first read it to yourself. Joe wants to deposit $1,000 into the bank. What letter do you think 100? What do you think 100 represents? Which letter? Good. I'm sorry, I'm going to go back here real quick. This is something we're still going to learn in this chapter. Remember, we're midway through this logs chapter. We just haven't got to this, but you could be tested on this, so I want to make sure to go through it with you. Okay, so this is your initial. And how long are you going to leave it in?
5 years.
So I know the T. I'm going to leave it in for 5 years, and I know how much I initially put in. His bank offers monthly compounds. So how many months are there in a year? So your N is 12. And here's the part that tricks people. It compounds at this interest rate, 3.8%. Now, a lot of people think, well, it's already as a decimal. It says 3.8, but behind it is a percentage sign. So when I turn it into just simply a decimal, what does this look like? Okay, so we're going to write this down, and then we're going to use the calculator to do the rest. Okay, here we go. So my final answer equals the initial amount, which is 100, then 1 plus the rate is 0.038. That's the biggest mistake I see students make, not converting it. The number of times it's compounded is monthly. Well, there's 12 months in a year, so 12 is down here. Again, n represents the number of times. So there's an n here, and there's also an n up top. So 12 also goes up top. And we're going to take 12 times t. T is the number of years you leave this in, which is 5. The rest is all done on a calculator. So grab your calculator. We're going to do it together. Now, we're going to start with parentheses. Do you think I should do the fraction first or the 1 first? What makes more sense? It should be the fraction and then add 1. So here we go. Ready? 0.038 divided by 12. Get an answer. Add 1 to it. We now have the answer for what's inside the parentheses. We're now going to do the exponent, okay? So we're following PEMDAS rules. So caret key, what two numbers do we need to raise it to? We need to multiply 12 times 5. Press enter, and your very last step is to take it times the number out front, which is 100. So after 5 years, Joe will have approximately $120.89. I rounded up to the nearest hundredth. Okay, I want you to press clear on your calculator. I want you to practice again and see if you can do it on the calculator. Can you plug it in right and get this answer? Go ahead. Is everybody good? Do you want me to help again? Yeah. Okay, ready, Rakeem? Grab the calculator. So we're going to do this first, okay? So take 0.038 divided by 12. And then add 1 to it. So I have calculated what's inside the parentheses. Good? Now I'm going to raise it to the in parentheses. I'm going to multiply the two numbers. That's not 12.5, it's 12 times 5. Then press enter. And then take it, t is the number of years you leave it in there. And then take it times the initial value of 100. Good to go? Yes, no? Yeah. Okay, you ready? I'm going to challenge you right now. Ready? Now listen closely. You're going to read this. If you are a female, I only want you, does everybody see this formula? If you're a female, I want you to write the formula right over here that you think belongs to bank A. If you're a male, I want you to write the formula that you think belongs to bank B. That's it. Don't touch the calculator. You don't need a calculator at all right now. See if you can do that in 45 seconds.
How many weeks are there in a year?
52. So Bank A offers a monthly. So women, you're going to have a monthly here. So it's going to be 1 plus, I know 12 is going to be on the bottom. And you all stay in for 6 years, so 12 times 6. And you all have initial value of 500. Now, the women have 3.9 interest. So in this spot, it's going to be How many women have this as your formula? Hands up high. Great. Okay. Women, I want you to calculate this for me right now and round to the nearest hundred. Okay, gentlemen, you have A equals the exact same initial amount, but this time you have a percentage of 0.0385 over how many weeks in a year? Well, Keem asked, there's 52 weeks in a year. Remember, this goes down here and also goes up above. And it's going to stay in for 6 years. Gentlemen, please calculate for me. If you disagree with me, I can definitely do it again. How many ladies came up with this answer? How many gentlemen were able to come up with this answer? Anybody? Only Carlos? Maybe I'm doing it wrong? Okay, Clell? Does anybody want me to do either one of these for you? Yes? Okay. Do you understand how to set it up? Yeah. Okay, here we go. Let's grab the calculator. Let's plug in 0.0385 divided by 52 weeks and add 1 to that. We've calculated the inside of the parenthesis. Now we're going to raise it to the 52 times, is it 6 years? And then we're going to take it times the initial value of 500. Good to go, Kevin? All right.